The next video in the puzzle of matter is on classifying matter. There are three learning targets we want to hit in this video. The first of which, we want to be able to differentiate between qualitative and quantitative observations. Whenever we classify matter by composition, we could do that in a qualitative way or a quantitative way. Qualitative descriptions are made without measurement. In other words, we might ask the question, what is it made of? An example of that would be sucrose or table sugar. It's composed of carbon, hydrogen, and oxygen. We could determine that without measuring, or we can state it without giving any measurements. A quantitative description is made with measurement. A question that might refer to that would be, how much is in it? So again, talking about sucrose, 100.0 grams of sucrose contains 42.1 grams of carbon, 6.5 grams of hydrogen, and 51.4 grams of oxygen. So these observations or classifications are made with measurement. I'm going to give you a statement, and I want you to determine if the statement is qualitative or quantitative. I would try to answer the question and then pause the video after the question and then answer it yourself, and then continue with the video to see if you got it right. First statement, the goalposts are 23 feet 6 inches wide. Is that qualitative or quantitative? That would be quantitative because we had to measure the width of the goalpost. It's made with measurement. The goalposts are yellow. That would be qualitative. We don't have to measure to make that observation. The goalposts are made of aluminum. Also qualitative. Again, no measurement is needed. The crossbar on the goalposts is 10 feet above the ground. That would be quantitative. It has to be measured. It was 87 degrees Fahrenheit when we put the new goalposts in the ground. Again, quantitative. That value had to be measured. The goalposts weigh 400 pounds each. Quantitative. That value had to be measured. The goalposts are hard. Qualitative. That does not need to be measured. So we've seen the difference between qualitative and quantitative observations. Next, we want to be able to differentiate between mixtures and pure substances. Whenever we make this distinction, we are classifying by purity. If a sample matter is a pure substance or is it a mixture. A pure substance, or simply a substance, same difference, is matter with the same fixed composition and properties. In other words, every bit of matter is the same if you were to take a look at every piece in the sample. Any pure sample is considered a substance. Some examples of substances would be gold, water, sucrose, and sand. So if we looked at a sample of gold and we looked at the particles that made it up, every single one of those particles would be exactly the same. They'd all be gold atoms. Same thing with water. If we looked at a sample of water, every single water molecule would be exactly the same. And we could say the same thing of sucrose and sand as well. A mixture is a combination of two or more substances in which the identity of each substance is not changed. In other words, the matter within that sample is not the same. The composition varies throughout. So for example, if you mixed white sand with sugar, that sample would have sand particles in it. It would also have sugar particles in it. They would not be the same, making that sample a mixture or not a pure substance. Now, could you tell a difference between the two? Well, let's say you added this mixture to water and you drank it. When you tasted it, you would be able to taste the two individual components of that mixture, the sugar and the sand, because the sugar is still going to taste sweet. You're going to taste the sugar that's dissolved in the water, but at the same time, you're going to feel the sand. Even though sand is tasteless, it is gritty. You're going to feel that in your teeth. So we can see that the properties of the two do not change even when they're mixed together, because they're still sand and sugar just like they were to start with. They just happen to be in the same sample. If you take a look at figure 1.12 on page 16, this would help with this explanation. Here's a practice problem. You need to identify each as a mixture or a substance. So ask yourself, if we take a look at a sample of this material, are all the particles going to be exactly the same, or will there be different particles in it? Carbon dioxide, that would be a substance. Every molecule of carbon dioxide would be the same. In fact, they'd all contain one carbon atom and two oxygen atoms, thus carbon dioxide. Salad dressing, that would be a mixture. Obviously, salad dressing is made of all sorts of different components, and you would be able to distinguish them based on the different particles. Air, it's also a mixture. It's made of all sorts of different gases, oxygen and nitrogen, the main two components, then also carbon dioxide and water vapor, and some argon as well, along with several other gases. Table salt, or sodium chloride, that would be a substance. If you take a look at a sample of salt, every particle will be the same. Sodium chloride molecules. Blood, that would be a mixture. There's no such thing as a blood molecule or a blood atom. Blood is a mixture of all sorts of different components. Oxygen. Oxygen is a substance. If you take a look at a sample of oxygen, every single molecule will be exactly the same. They would be composed of oxygen atoms. We now want to explain how mixtures can be separated. If we're going to separate mixtures into substances, what we need to understand is that all mixtures can be separated into its component substances by physical processes. This does not change the identity of the substances. The substances that were in the mixture will still be those same substances. So for an example, how would you separate a mixture of sand and sugar? I suppose you could put the sample under a microscope and physically pick through it with a forceps or a toothpick or something like that, because under a microscope you could see the different shapes of the particles, but that would be a very painstaking process. It would take forever. What about this? You could place the mixture in water. The sugar will dissolve because it's soluble in water, while the sand will not. It's not soluble in water. You could then filter out the sand and then boil the water away from the resulting solution, and that would give you the sugar left over. If you take a look at figure 1.13 on page 20 of your text, this will show this example. What we're showing here is that mixtures are separated by physical changes. They take advantage of the different physical properties of substances in the mixture. In the example we just mentioned with the sand and the sugar, the difference in physical property that we're using is the solubility. Sand is not soluble in water, while sugar is, which allows us to separate them. Some examples of different physical properties that could be used to separate substances in mixtures: differences in boiling points, freezing points, solubility. All these are physical properties, which is a property of a substance that can be observed without changing the identity of the substance. So for example, if we want to determine whether or not sugar is soluble in water, we put sugar in water, we see that it dissolves, and we know that it's soluble. We don't change the identity of the sugar in it. It's still sugar. In this practice problem, you want to explain how you would separate a mixture of iron filings and sand. Describe the property that allows you to perform this separation. Well, in this case, we would use the fact that iron is magnetic while sand is not. If we run a magnet over the mixture and through the mixture, the iron will be attracted to the magnet and it will separate from the sand. Next practice problem. Describe how physical properties allow mixtures to be separated. If we have a mixture, by definition that mixture is going to contain different substances. And because there are different substances there, they have different physical properties. It's this difference in the physical properties that would allow us to separate the substances in the mixture. Examples of differences in properties would include solubility, melting and boiling points, magnetic properties, and appearance.